Okay, math for college students, we're going to talk about circles now. It says, given the circle has a center of HK and a radius of R, the standard form, it says from, that should be form, sorry about that. Standard form of the circle can be written as, this is your formula, x minus h quantity squared plus y minus k quantity squared is r squared. And this actually comes straight from the Pythagorean theorem. And as I said, it comes from the Pythagorean theorem. You can see that this is like a squared, this is like b squared, and this is like c squared. So the Pythagorean theorem, the distance formula, and circles, they are all heavily related. And so kind of a neat thing, and that's why we kind of cover them together. If the center is 0, 0, that means that h is 0 and k is 0. Watch what the equation turns out like. You got x minus 0 squared, y minus 0 squared is r squared. So x minus 0, that's simply just x. Y minus 0 is y. It's r squared. So you can see that definitely looks like the Pythagorean theorem right there. So this is new for you, but this is not something that has to be complicated. We're going to make it nice and easy. It says write the equation for a circle with the following properties. The center is at -3, +2, and a radius of 4. So again, we want to use this formula, x minus h quantity squared plus y minus k quantity squared is r squared. So this is h, and that's k, and that's r. So we have x minus -3 squared, y minus 2 squared is 4 squared. Now we don't leave it like that. You're going to write it as x plus 3, because when you subtract a negative, it becomes positive. And then plus y minus 2 squared, and then 4 squared is 16. So this is how we're going to write it. And what I want you guys to understand is that as you look at this x plus 3, that means the center had an x value of -3. And as you have this minus 2, that means it had a y value of +2. And as you have a 16 on the end, that means that the radius was 4. So keep that in mind. The next one, we have x minus 0 squared plus y minus -5 squared is 1/2 squared. That becomes x squared, y plus 5 squared, and then 1/2 times 1/2 is 1/4. Next one, we have x minus 3 squared plus y minus 0 squared is 3 roots of 2 squared. So that's x minus 3 squared plus y squared is, you square the 3, you get 9. If you square the square root of 2, you get the square root of 4, which is 2. So you end up with 18. Now, given the equation, let's identify the center and the radius. So the center is going to be 3 for the x value and -2 for the y values, opposite what you think it is. And the radius is 4. It's the square root of that thing. Here, the center is 0 for x and -3 for y. And the radius is the square root of 48. You could take a perfect square out of that. You could take the square root of 16. So the square root of 16 is 4, so we have 4 roots of 3. Here the center is -3, +5, and the radius is 7. Here the center is 7, 0, and the radius is the square root of 12. You can simplify the square root of 12, square root of 4 times square root of 3, or 2 roots of 3. All right, final example. It says show that the following equations represent circles by placing them in standard form. Okay, so first you need to understand a little bit about these equations. Notice that we want to make it look like x minus h quantity squared plus y minus k quantity squared is r squared. That's what you want it to look like. But you can see it doesn't have any of those completed square things. Now, what is a completed square? We'll show you. For example, x plus 5 squared. That's x plus 5 times x plus 5. As you multiply this out, you get x squared plus 5x, and 5x is 10x plus 25. So this is actually a perfect square because it factors down to this. I'll give you the example of another perfect square. X squared plus 14x plus 49, because it factors to x plus 7 squared. Here's how you know it's a perfect square. If you take this thing and divide it by 2, you can see you get 7. If you square the 7, you get that. So we take the middle number divided by 2 and then square it. If you get the end number, then it's a perfect square. Watch. 10 divided by 2 is 5. Squared is 25. I'll show you another one. X squared minus 6x plus 9. Negative 6 divided by 2 is negative 3. Squared is 9. Factors x minus 3, quantity squared. So here's how we put it in that form. We gather our x's. So we have x squared. We have minus 8x. So I've used those two. And now we're going to do plus y squared minus 12y. So I've used those two. And then I'm going to add the 7 over on the other side. Now, what we have to do is we have to complete the square. So we're going to add something here. What are we going to add here to complete the square? We're going to take that negative 8, divide it by 2 to get negative 4, and then square to get 16. If you added it to one side of the equation, you add it to the other side of the equation. Look at this one. Negative 12 divided by 2 is negative 6, and you square it and you get 36. If you add it to the left side, you got to add it to the right side. This factors to x minus 4 times x minus 4, or x minus 4 squared. The next part factors to x minus 6 times x minus 6, or y minus 6 times y minus 6, or y minus 6 squared. And then on the other side, you have 7 plus 16 is 23, plus 36 is 59. That tells me that the center is 4, 6, and that the radius is square root of 59. So this is a little bit involved. You might have to watch that again, but let's try another example. Gather my x's. I only have x squared. Gather my y's. I have y squared and minus 6y. I'm going to add the 7 to the other side. This is already a completed square. It's done. So if I'm going to complete the square here, I'm going to take that negative 6 and divide it by 2 to get negative 3. I square to get 9. We have x squared. we have y minus 3 times y minus 3, or y minus 3 quantity squared, is equal to 16. Now I know what the center is. The center is 0, 3, and the radius is 4. And there you have it. Should be ready to start your assignment. We will see you guys in a Google Meet.